Hello guys, so in today's video we are going to discuss the solution of the problem statement longest substring without repeating characters. Okay, so let us first understand the problem statement. So the problem statement says that we are given a string s, so this string is given to us. We have to find the length of the longest substring without repeating character. So we have to find out the longest substring such that it does not contain any repeating characters to it. So for example, in this particular case, ABC, ABC and BB. Okay, so let me work with the example. Let me switch to this. Yeah. Okay, so in this case, the example was, let's say the string which was given to us was A, B, C, A, B, C, B and B. Okay, so then and the output was we had to return 3 here. Okay, so basically the longest substring, if you could see, without with a non-repeating character is this. So this is the longest substring which we have without non-repeating characters, and the length of this substring A, B, C is 3, and that is how we are returning 3. Okay, so that's about the problem statement. Now let us discuss the solution for this problem. So the first solution we are going to discuss is the brute force one. Okay, so the brute force solution, basically in the brute force solution what we will do is we will go ahead and generate all substring of the possible length. Okay, so let us say the string s is given to us. So let's take the same substring, sorry, the same string abc, abc, bb. So the length of this string is how much? 3, 3, 6 and 2, 8. Okay, so 8. So the size of the substring, size of the substring will be, basically it could be either 1 or 2, 3 dot 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 till 8, right? So that those are the so we can generate a substring of size 1. So let me write it down as substring, and let us say the size 1, I'm representing it as 1. So the substring of size 1 are basically A itself, B, C. Okay, so these are the substring of size 1, right? Because so the substring should not have repeating characters, so that's why these are the unique substring which we could generate. Similarly, the substring of size 2 could be, sample examples could be AB, BC, right, and various others, right? Similarly, we can compute the substring of size 3, substring of size 4 and substring of so on till substring of size 8. Okay, so we'll compute all these substrings and we will see which, so for instance, if you compute the substring of size 3, okay, substring of size 3, then the possible answers could be over here is A, B, C. Okay, so the first 3 characters, or it could be these characters also, right? So it could be BCA and various others. All right. Now, if you try to compute a substring of size 4, then the substring of size 4 is null, right? It's a phi set because there isn't exist any substring without non-repeating characters. So, for instance, if you take these, let me use this. Yeah, if you take the first 4, A is repeating here, right? If you take any 4 characters, any substring of size 4 from the given string, we would not be able to find a substring which will suit our definition of the substring. So thereby the answer to this is 3. This is the brute force approach wherein we are going ahead and generating all the substring possible, and then for all the substrings which we are generating, we are trying to find out which is the maximum length substring which is in accordance to the problem given to us. Once we find out that, we go ahead and return the size of that substring. Okay, so that's about the brute force approach. But that is not what, since it's a brute force approach, and we can say that the number of substrings generated would be of order n squared. Okay, would be of order n squared. So the running time complexity of the brute force algorithm would be of order of n squared, because of which this is not an optimal solution, and we will be exploring an optimal solution for this. So let us look at the optimal solution. Okay, so let me look at optimal solution. Okay, so in the optimal solution, basically what we can do is, so let us say we are given that the same substring a b c, b, b. So what we will do is that we will iterate from the 0th index, and we will go till all the way till nth index size of the string. While doing so, we will go ahead and create a dictionary. Okay, so the way I am suggesting is, let's say this is my dictionary or a hash, basically dictionary in terms of Python I am saying. So we are creating a dictionary where the key is the character at the index I. So let us say a, we are at index I, the value of a is 0, right? So the key is the character and the value is the index at which the character is. So we say okay, a, so we will see first whether the character, so the algorithm goes something like this. Let me write it down. Okay, so we will check if, so what we can do is basically for I in range length of string. Okay, so I'm iterating on the string, and we will check if the I is in the dictionary. If the I is not in the dictionary, we will make an entry in the dictionary, and let us say we have a counter which gives me the current length. Okay, the current length of the substring. So right now I have just scanned one character. It was not in the dictionary. That is why the length of the, so I made an entry in the dictionary and the current length is 1. The next thing is that I'll increase my I to 1, and now I'm at bth character. So again, b is not in the dictionary. I'll make this entry in b and the index is 1. And again, I'll increase current to 1 by 1, right? So this becomes 2. Now I'll come to C. C, we will see that C is also not there in the dictionary, so we'll make an entry in the dictionary, and then I'll increase my current length counter to 3. Okay, so on. If the character is not there in the dictionary, what are we going to do is that we'll make an entry in the dictionary and we will increase our current length counter. Now what happens if the character is in the dictionary? So for instance, we are at this character now. We are at this character now, and we see that it is there in the dictionary. Okay, now since it is there in the dictionary, now the substring will be of the substring would be this, right? So the last occurrence of a, the first occurrence, if I could say that, the first occurrence of a, the next element to the first occurrence of a, which is b in this case, from b to all the way to the current index would be my length of the substring. So that is what I'll go ahead and do it. Now, so what will happen here is that the current length, we will update the current length. The current length, how are we going to update it? So the current length is basically is equals to I minus when was the, so we'll see the index at which it was repeating. So this was the index, right, at the 0th index, and this information is stored there in our dictionary. So the 8th index, okay, so that information we can get it from the dictionary, and we will subtract that information. And since we are dealing with, so in this particular case I is 3, 0 1 2, sorry, 0 1 2 and 3, yes, I is 3, and the index of A is 0, so 3 minus 0. And since okay, sorry, so we are trying to compute the current length, so the index will, so A and the length of the substring becomes from here, so next to A. So the index of 0 was the index of A was 0, so we have to add 1 to it, and that's how it becomes 1. So the length becomes what? 3 minus 1 plus 1. The additional 1 is because since we are starting our index from 0. Okay. So that's how the length becomes 3. So the current length becomes 3. And once we have updated our current length, we will go ahead and update our A to the latest entry of A, which is what? To 3. So the latest is 3. Okay. So that is how we will go ahead and iterate it. So that is how we will iterate over the string S, and we will keep on updating the dictionary, and we'll keep on updating current length. And in every iteration we will have a variable which holds the maximum length. Okay, so the maximum length was 3 here, again 3. If it increases beyond 3, we will go ahead and update our maximum length to that particular value, and basically the maximum length will contain our length of the substring. The maximum substring length will be there in the maximum length. Okay, so that is the approach of the optimal solution. As you can see, the optimal solution, in the optimal solution we are iterating the string just one, so the running time complexity is order n, and in worst case the space complexity we would be needing is order of n. Okay, so okay, let us do one more example just to be on a very safe side, and then we will go ahead and look at the code. So let me switch back to my editor. Okay, so the next example is basically pwwkew. Okay, now let's go back to this. Yep, and so let me take a new page here. Yes, so here the string was what? pwwkew. Okay, so now let's have a dictionary here. Dictionary. So initially the dictionary is empty. Okay, and this would be our, so initially our current length is equals to 0, and the max length which will contain our answer is some negative infinity. Okay, now let's start. So we are at this. Okay, and since p is not there in the dictionary, so we'll make an entry of p over here, and the index is 0. Okay, and let us update our current length. So the current length, in short I'm writing it as CL. Current length becomes 1. Okay, and let us update our max length also. Since 1 is greater than max length, so max length becomes 1. Okay, so now let us take let's go to the second character, which is W. Again, W is not there in our dictionary, so W, and we'll make an entry over here. Again, so the current length will increase it to 2. Similarly, since the current length has been increased to 2 and max length is less than current length, so we will go ahead and update our max length. So far till pw, the maximum length substring is 2. Okay, now the third entry is again 2. sorry, the third entry is again W. W is there in our dictionary. So first we will go ahead and compute the max length. So the max length is what? Max length is the, so W is what we are expecting. So the last entry of W, so the last entry of W was at index 1, which is this, okay, plus 1, right? So plus 1, right? So we will be here basically, all right? And then the length becomes what? So the length becomes just 1, right? So we'll be here at W, and then it's just a single character. So that is how the length, current length is 1, since so in this case the max length remains 2. And by doing so, let us now update the W over here. So now the W becomes what? 0, 1 and 2. So this becomes 2. Okay. All right. And now let us look at the next one, which is K. Okay. K. So let us add. So K is not there. So now K can be added over here, and the length, current length becomes 2. 2 is already there, so the maximum length remains 2. Again we will see E. E is not there in our dictionary, so we will have it over here, and this E becomes 3. Now since the max length, so we will update our max length to 3. Now again we will see, okay, W is already there, so W is where? At the second index. So let us go to the second index. So the second index is basically here, 0, 1 and 2. So this plus 1. So the substring is basically KEW, right? So again, so KEW, the length is 3 here, okay, and the max length remains 3, and the maximum length is what we are going to return. So maximum length is 3, so this is what we are going to return. Okay, so that's about the explanation and the algorithm. Now let us go ahead and implement this solution in the editor we have. Okay, let me go back to the editor. So let us look at our code for this. So the code is something like this. So what we will do is that we will check if it is an empty string. So since it could be an empty string also, so we are saying that if it is an empty string, then naturally the max length substring would be 0. So that is what we are returning. If it is not an empty string, then we need some variables over here, which is substring start, and so we'll have current length as 0. We need a dictionary, and we need a max length, which we are initializing it to -infinity, and the substring start, so the starting index of the substring. Okay, now we will see if the character is not in the dictionary. If the character is not in the dictionary, then we will add that character in the dictionary. So that addition is happening here, and we are increasing the length by 1. Okay, if it is part of our dictionary, and remember in this case when we are increasing it, then the substring start remains what was its initial value. We are not changing the substring start value. The substring start value will be changed once we see repetition of the character. Okay, so that is what over here we are doing. So if it is already part of our dictionary, which means it's a repeated character, so now we have to find the right substring start point. So the right substring start point is basically the last repetition of the character, and then the next one, right, and then the next index basically. So that is what is we are updating it over here. But this we have to safeguard it with this condition. This is because that we should not fall back, right? The substring start should always be in an increasing fashion. It cannot fall back. Okay, because of which we have guarded it with an if statement. And once we find out the substring start, then all we are left is to compute the length. Length is equals to this. That is how we compute length. And we need to update the index of the occurrences of the latest occurrence of the character we need to update. So that is what is being updated here. And then once all these things are done, we go ahead and compute the max length and then we return it. Okay, so now let us try to run this. Okay, I think it ran. All right, it ran and we have these 4 cases passed. Now let us submit the solution. Okay, so the solution got accepted and this is the result. So that's about this video, guys. If you have any questions, any confusion regarding this explanation, please feel free to drop it as a comment. I'll try to address them. Thank you. That's all from this video. Thank you.